Okay, so this video is just looking at Kirschoff's law. So I'm just going to use this little circuit here to explain these two rules. Okay. So basically, before this, we were just using our simple series and parallel circuits rules to look at what was happening in parallel and series bits of our circuits. I guess what Kirschoff's law gives you is a law that applies to all circuits. And so this allows you to look in any closed loop in a circuit. We know that through Kirschoff's law the sum of the voltages around the loop is going to be 0. And like we said, this is basically a statement of conservation of energy, okay, because we're thinking about voltage in terms of the energy that it's giving to our electrons. The thing when we're applying Kirschoff's law is that we have to think that some voltages are going to be opposite to others, and so we can have positive and negative voltages. So the first thing to understand is, what do we mean by an opposite voltage? So if our current is going through a component, it's either going to lose or gain energy. So the way to think about this is that every component is going to have a higher potential or sort of energy per coulomb than the other. So the high potential end of a battery is the end that the current leaves, okay, so because the current's going to gain energy from the battery, and the high potential energy of a resistor is the end that the current enters, because the current's going to lose energy as it goes through a resistor. So if we're looking at our voltage supply, then this is going to be our high energy or high potential end, and this is going to be our low potential end. And if we're looking at our resistor, the current's going to be going in this direction, so this is going to be the high potential end and this is going to be the low potential end. Now I think it's kind of important to label these as you're thinking about, before you start thinking about writing your loop equation. If you go around and make sure that you label the high end and the low end of each of your components, it's going to be much easier when you come to think about, is it gaining or losing energy as we go around the circuit. So once you've done that, the next thing to do is decide the direction of your voltage across each of the components. That's going to help you decide whether the voltage is going to be positive or negative. Okay, so there's different ways you can do this, but this is just one of the ways. So one of the ways you can do it is to draw an arrow next to each component that points towards the high potential end. So at your batteries, your voltage supply is going to be fairly straightforward. Okay, the high potential end is always the positive terminal. For a resistor, what you've got to do is decide which of your three currents goes through it. So there's got to be no junctions between the resistor and the marked current direction. Okay, so here we've got I1 going through the 4 ohm resistor and I3 going through your 2 ohm resistor. Okay, you can draw some little arrows alongside each of the components pointing towards the current entry end. Okay, so if we think about where we're going to draw these on our diagram, we've said the high potential end is always for the positive terminal. Okay, so we're going to go from high to low. Okay, and then excuse me, we're going to think about which way it's going to go through each of these resistors. So we want our arrow pointing to the high potential end of our battery. Okay, so hold the wrong way around. Okay, so here's our high end here, high end here, and high end here. Okay, so we're going to put 3 little arrows here, so you can't see that one. And then we're going to look at where our high end is on our resistors. So when it's going through our resistors, okay, we want these little arrows to point towards the current entry end. Okay, so if our current is coming round, I1 is going through this, so the current entry will be at this end here. Okay, same on this one, so our current's going to be coming in, so we want the arrow pointing to the end where the current's coming in. This is our high end. Okay, so then we've got to look and decide which of our voltages are positive and which are negative. Okay, so within any of our closed loop in the circuit, the arrows alongside each component are pointing either clockwise or anti-clockwise. One direction you've got to choose as the positive direction when we're going to go around the loop. It doesn't matter which one. Okay, and then we're going to apply it to each one of these loops. So we'll call this side loop A and this side loop B. Okay, so we'll look at loop A first. Okay, so I'm going to look at going round in a clockwise direction. It just makes more sense in my head that way, but it's entirely up to you. So when we're going around clockwise, we're going in the same direction as the arrow that's next to our 9-volt battery. That's going to be plus 9 volts. Okay, then we're going to come around here, we're going against the arrow here. It's going to be negative 2 volts. And then we're going against the arrow as we come round and through our 4 ohm resistor. So we're going to have I1 going through our 4 ohm resistor. So it's going to be I1 times by 4, and all of that is going to equal 0. So for loop B, again we're going to do the same idea, and again I'm going to go around this clockwise. I'm going to start at the 3 volts. So we've got plus 3 volts going across here because we're coming we got minus 3 volts there because we're going against the arrow. This is the 3 volts, sorry, this one here. Okay, and as we come around here, we're going against the arrow again. So we've got I3 multiplied by 2 ohms, and then we're going to go with our 3 volts here. So that's going to equal 0. So if we have a look at loop A, we could then go on and actually work out some of these calculations. So we've got plus 9 take away 2 gives us 7. Okay, and then we've got I1 multiplied by 4. So if we're going to work out I1 here, we'd end up with 7 over 4, 1.75 amps. And we can go on and do further calculations with those. So if we wanted to go on and look at loop B, that would help us work out I3. So we've got minus 3 minus 2 times I3 plus 3 is going to equal 0. Okay. Okay, so we end up with I3 equaling 0 here, which doesn't make sense. Maybe I've drawn one of these batteries the wrong way around. Anyway, you get the idea. Then the second rule that we have with Kirschoff's law is our point rule. So if we look at a junction here, okay, where we've got currents coming together, we're going to have I3 coming in to the junction and going out. We've got I1 and I2, so I1 plus I2 is going to be equal to I3. So if from here we'd been able to work out I1 and I3 successfully, this doesn't make any sense, but we would also have been able to work out I2 then as well. But hopefully that gives you a little bit of help with how to set up these diagrams before you start writing your loop equations. If you don't set up those, you know, your actual circuit diagrams, put some arrows in and think about what's the high side and what's the low side of each of these components. It makes it very difficult to actually successfully negotiate yourself around those loops. Again, like I said, I know that some of you are actually struggling with some of the questions in the assignments on these, so you'll find there's some videos later looking at some of those questions with Kirschoff's law, so you can have a look through those and have a re-look at some of those questions.